Welcome back to the course on architectural design of ICs. So, we are discussing in the last class about the multiplier architecture. So, we have seen this the basic multiplication operation, which is the serial multiplier architecture. So, apart from that, in combined with parallel multiplication operation, that means parallel as well as the serial, how we can do that type of architecture also we have seen. Okay. So, then again what I said that the basic multiplication operation is nothing but this shift and add. Okay. So, that are the basic fundamentals of any multiplication operation. So, that type of adder architecture now we will see. So, where this is nothing but that shift and add. Okay. So, here you see I am having two input, which is A in and B in. Okay. So, each of if I consider each of them are of 8 bit. Okay. So, I am having 8 bit register over here for input A in, and I am having 8 bit register for B in. So, based on that, okay, based on that I am having one adder over here, okay. So, where this adder will again one of the input to the adder, that is the corresponding shifted bit of this B, and this another, that means sorry, not shifted bit of this. So, the shifted that means this addition operation, they are basically controlling the this B in. How, what is the how basically this circuit is operating, that I am just coming later. So, I am having two registers of A in and B in, and I am having one adder. Okay. So, what I need, shift and then add. Okay. So, then addition operation, this after this getting the sum, they will be stored somewhere, that is this particular register. Again, what I basically need to add, what I need to add. Okay. If I consider this particular case, so if I need to, that means do this addition operation, suppose A into B I have to do, A of 8 bit and B of 8 bit, right. So, at that time what will happen, initially what will do, I have to, I will get A, okay. Considering, suppose if I consider all the bits of B are 1. So, at the time how we can do, at the in the next I will get 2A, then I have to add 4A, then I will get 8A, then I will get 16A, something like this I will get. That means what, I am shifting the A in for 1 bit left shift. Okay. And if this bit is 0, if any of this bit is 0, so at that time it will consider not A, it will consider or it will choose 0. So, that means what I am doing, suppose for this particular case, so initially it will not be A, it will be 0, and in the next if it is 1, so at that time I have to get 2A, and that will be come to the adder. That means this 0 will be come at first, then that will be added with 2A. Then in the next, if this is 1, so at that time this 0 plus 2A is already saved in C register in the previous particular, that means architecture. Then if I consider this 1, so at that time what will happen, this will be shifted by 2 bit left shift. That means at that time I have to add 4A. If this bit is, suppose this bit is 0, so at that time this will be added with 0. So, that is why if I just go back to this particular case, so you see whenever this, basically what is happening, this is the input bin, B in. Okay. So, B in is loaded over here, and A in is loaded over here, right. So, initially if I, as for this previous example, what I consider that, let us consider the first bit is 0. Okay. So, that means this bit is 0. So, that will come over here and it will choose 0 instead of A. So, then 0 is the one input and it is connected to the feedback. So, that means now 0 plus 0. So, this 0 will be stored over here. Okay. So, then again that bit will be, that means if the next bit is 1, suppose this is initially it was 0, then it is 1. Okay. So, then 1 coming over here. So, it is choosing this particular A in, okay. And then 0, that is again added with this particular case. Okay. And here whenever we are choosing this A in over here, not, that means based on this what value of A. So, what is the weight of this, that I need to calculate, whether that will be 2A or that will be 4A. So, here using this marks I can compute that. Okay. So, for 0 this will choose 0, if this bit is 1. So, at that time it will choose 2 of A, that means whether the A in will be just shifted by 1 left shift, and that will come over here and that will be stored in this particular register. Okay. So, in this manner, now in this manner that will be saved. And how in that means how we are doing this particular, suppose for this case if I consider suppose if I consider, suppose for A, that is 1 1 1 1 1 1 0 0, okay, and let us consider 1 0 1 0 1 0 1 0. Okay. So, initially what is happening, 0 is coming. So, this is filled with all 0. So, that means this register C at the very beginning it is filled with all 0. Okay. So, then it is choosing A, that means this 1. Okay. So, that now all this is 0. So, this 0 is basically coming over here. Okay. So, then this bit is shifted, that means at that time this range A, range B will be 0 1 0 1 0 1 0 1. Okay. Then 1 is basically coming over here and it is choosing this A. So, here initially it was 0. So, at that time range C is nothing but your 1 1 1 1 1 1 0 0. Okay. So, then again this 0 is basically coming over here. So, register B will be 0 0 1 0 1 0 1 0. Then again it is 0, means it will choose 0. So, at that time 0 added with this. So, that means now range C will not change its value, correct. So, that means it will remain 6. Then again this 0 will come over here. So, that means now register B, the value of register B, that will be 0 0 0 1 0 1 0 1. Then again this one will come out and again it will choose A at this particular case. So, at that time what will be the values of register C? That will be A plus A, means what? That is twice of A. Okay. So, A plus A means twice of A. So, that means now it will be it will be 1 1 1 1 1 1 0 0 0. Okay. So, that means now this one will come over here. Okay. So, now again this 0 will come. So, that means now at that time register B, that will be 0 0 0 0, then 1 0 1 0. So, then again 0 means register C will remain same. So, it will be come over here. So, register B again, that will be changing its value to 50, then 0 1 0, sorry 1 0 1. Okay. So, then again A, one of this will come. Okay. So, that means again I have to add this with A again. So, that means now C register will be 3 i's of A, okay, and this will be in this manner, it will be this C will be finally, that will be of 4A, here it will be 4A, and all these bits will be 0. Okay. So, now if I, that means the results whatever is the remainder over here, okay. So, that is the results of 15 down to 8 and the results over here which is remaining over here. So, that is the results 7 down to 0. That means what? Now, if I just do in other way, that means whenever I am multiplying, suppose this is A, I am multiplying with whatever, what is the value of this, that is 1, then 2, sorry 1, then what is the value of this 0 1 0 1 0 1 0 1. So, the value of this is 1 plus 4 plus 16 plus 32. So, that means total 53. Okay. So, in this manner, now if I just, that means calculate, okay. So, okay, actually I have to draw, not, it will not come as 4. So, finally, what value I will get over here, okay. So, that will be in as I am doing this shifting operation in this particular, as in this case. So, it will give me the corresponding weight of 53 as I am accumulating A over here in this case. So, that means whenever I will shift this particular, based on this will be shifted and then again it will come over here. Okay. So, in this manner I can do this shift and add operation. Okay. Actually, if I consider another example, at that time it will be much more clear. So, whenever you are following, so at that time you choose any number over here and you choose any number over here and you do, that means how this operation basically is happening, and then you see whether you are getting the correct results for that or not. Okay. So, suppose, okay, let us consider another example. If I choose only this value, 3 value if I consider, for a smaller value, I think at that time I do not need to that much of. So, if I consider 3 over here, so at that time what will be the register C? Okay. So, the register C will be, it is 1 and it will choose A. So, that means it will be A, okay. And A means what? Whatever is the value of this, that will now come to this particular position, right. Okay. So, then what will be the register B? If I choose that as, suppose this value of this is, so the register value of, that means this will be all 0 and that will again shifted to this particular case. Okay. So, that means now again this will be added So, initially 1 it is choosing this A, okay. Then again this is 1, then again that is register A will be A plus A, that will be of 2A. Then again in the next, this what will be the register B value? If that is 0, then that 0 will come over here, and then again it will try to push this one, and then again it will come down to this, it will choose at the final this register C will be added with A plus A plus A, and all the corresponding B in value, that will be all zeros, or the whatever is the values of this, that A in will try to fill this position. Okay. So, in this manner, in this fashion, we can, that means do this shift and add multiplication. Okay. So, it will be better if you choose your own particular numbers over here, and then you try to calculate the corresponding multiplication operation. Okay. So, then we have this synchronous shift and add multiplier. That means, whenever we are doing this multiplication, shift and add, so at that time there are two type of multiplier, which one is synchronous, another one is asynchronous. Okay. So, in synchronous shift and add multiplier is very much that means common in use. So, they have 5 states which are idle, initial, test, add and shift and count. So, in the idle state, it starts by receiving the start signal. That means, whenever this start signal will be 1 or high, it will start the operation of the corresponding multiplication. And in the initial case, the multiplicand and the multipliers are loaded into the load register and a shift register respectively. That means what? In this case, this A, whenever initial signal is high, so the A in and the B in, that will be loaded into two corresponding register. Then this test signal, the LSB in the shift register, which contains the multiplier, is tested to decide the next state. Okay. So, if LSB is 1, then next state is to add the new partial products to the accumulation results, and the state machine transits to shift and count state. Okay. That means, what I said, that whenever, that means this LSB of this is 1. So, at that time what I have to do? I have to do this addition operation and shift and count. That means, this shift and count also I have to perform, right. Then in shift and count, if LSB is 0, then two shift registers shift their contents 1 bit right, and the counter counts up by 1 step. After that, the state machine transits back to test state. When the counter reaches to n, a stop signal is asserted and the state machine goes to the idle state. And in the idle state, a done signal is asserted to indicate the end of the multiplication operation. Okay. So, that means now what is happening? How many times I am basically doing this 1 over here, I am getting 1 over here. So, that is being counted. Why I need to count that? Because based on that, what I said, that I have to add something like this, A and then 2A, then 3, then 4A, something like this I have to add. So, how many times I am basically adding? So, that I have to do. So, this is what I am getting over here? In this particular case, how many times? So, if I am getting 3 times 1 over here, so that means based on this I will get the corresponding weight. So, that means this is what? This is 2 to the power 0, then 2 to the power 1, this is 2 to the power 2. So, total 7 number of shift I have to do it in A, or 7 times I have to add A, something like this. Okay. So, that is why based on this, based on this particular case, now I can. So, this is the controller design, that means this is the condition. If the LSB of B is 1, then add and then shift and count. In shift and count, if the LSB is 0, then do the, that means go to the, that means the counts up by 1 step. If the counter reaches to n, that means what is that n is the number of bit, or if it is in this particular case we have considered that as 8. So, if it is reaches to n, so at that time stop the signal, and whenever this stop the signal, that means finally the results is done and you just break the loop or come out to the output. Okay. So, this is the shift and add multiplication operation. So, here you see this is the multiplicand, then there is a n bit adder, and then there is this shift and add control logic. So, this is the corresponding A and this is the corresponding this B, here it is considered as Q. So, whenever this Q0 is basically it is checked in each of these things, whenever this is 1, so at that time it will follow the logic what I discussed, and if it is 0, then it will follow different logic. Okay. So, based on that it will be just added something like this in a repetitive manner. Okay. So, this is nothing but a synchronous shift and add multiplier, the same thing. Okay. So, and then what I said that I am having two type of multiplication, what is synchronous, another one is asynchronous. Okay. So, this is the basically this computation time requirement in synchronous, as this is happening, that means all the things are happening clockwise. So, that is why I have to wait for more time in synchronous, otherwise actually I have not discussed the asynchronous circuit here, but if you follow the asynchronous circuit for this, that means some of the changes or some of the that shifting operation that you have to here what is happening, basically this in particular clock it is finding the LSB position of B, then not finding, it is checking the position of B, and then it is tries to do this shifting operation and count operation, that means added by this one, and again it is also doing that addition operation too on the same clock edge. But in asynchronous design you can do it in a different way. So, that means that will not happen in one particular clock cycle. Okay. So, that is why this time requirement in asynchronous case that are lower than the synchronous case. Okay. But then what is the problem in asynchronous case? So, you can get, that means that whenever you are doing the operation, so at that time you can get more violation, that means more violation means if one of the signal is not coming at to any particular gate at proper time, so at that time there will be mismatch in the results. So, that means if the data is not properly aligned, so at that time you will get erroneous results, or that means garbage value at the output, which will not happen in the case of synchronous circuit, but which can happen, or which there is a high probability to for happening the that type of things in asynchronous circuit. But what I am getting? I am getting the computation time is much more lower than the synchronous circuit. Okay. And apart from that, the circuit chip area, that is also more in this case of asynchronous circuit, as we are putting some extra logic to pre-compute the values. Okay. So, this is the comparison between this synchronous and asynchronous circuit. Then, so this up to this is this shift and add based multiplication. So, what we have learned? Serial multiplication, then serial plus parallel multiplication, then shift and add based multiplication. So, in shift and add based multiplication, there are synchronous multiplication and asynchronous multiplication. Then there are this array multiplication. So, array multiplication is also the regular structure which is based on this shift and add based algorithm. Okay. So, here the main thing is that this addition is mainly done by carry save algorithm or carry save addition operation, and then sign bit extension results in a higher capacitive load and slow down the speed of the circuit. So, that means why I need to, if I am doing this sign multiplication, so at that time I have to consider this sign bit extension, otherwise I do not have to. Okay. So, whenever I am doing this using this array multiplication, I can do sign multiplication as well as unsigned multiplication, but whenever I am doing unsigned multiplication, at that time I do not need anything. But whenever I am doing signed multiplication, so at that time I have to be bothered about the signed extension. So, how we do sign extension, that will come later. Okay. But whenever we are doing the sign bit extension in array multiplication, so at that time, that means I am putting extra overhead to the circuit, okay, which basically degrades the performance of the, or that is the disadvantage of this particular architecture. Okay. So, we will discuss more onto this on the next class. So, thank you for today.